Now we are discussing operating point of a transistor. We already know this transistor is operating as an amplifier. What is this operating point? This operating point particularly gives the output voltage and the output current at which the transistor is operating. We are taking all the possible values. The supply we are giving is VCC. This is the supply. And the current across the resistor is IC. So the voltage drop is ICRC. And the remaining voltage drop is VCE. So this is VCE. So entire supply is distributed to this resistor, that is ICRC, and the remaining voltage is given to the transistor, that is VCE. This VCC is fixed. This RC is also fixed. We have only two variables in this equation. One is IC and the second one is VCE. These are the output characteristics of common emitter configuration. On the x-axis we have VCE, on the y-axis we have IC. On the x-axis we have VCE in volts and on y-axis we have IC in the milliamperes. In this equation, because VCE is on the x-axis and IC we are representing on the y-axis, I am interested to make this line in the form of y is equal to mx plus c. I am representing this line in the form of y is equal to mx plus c. Okay. So now ICRC equal to VCC minus VCE. IC is equal to minus 1 by RC VCE plus VCC by RC. This is Y. M, slope of the line, negative slope. That's why we have drawn decrementing line. This is X. This is C. Now we have drawn a line. Across this line, transistor can operate. Sir, how you can say this is the line? Can I take in the fourth quadrant or in the second quadrant? No, not possible. Why? Because the maximum, we will, after finding the x-intercept and y-intercept, we will come to know. We will first calculate the x-intercept and y-intercepts. The slope of the line we already know, this is minus 1 by RC. In order to calculate the x-intercept, we have to make the point y as 0. Here the y is this. So when I am making IC equal to 0, then minus VCE by RC plus VCC by RC. Therefore VCE is equal to VCC. This is the x-intercept. In order to calculate the y-intercept, we are making the IC as 0. In order to calculate the y-intercept, we are making VC as 0. So IC is equal to 0 plus VCC by RC. So this is 0 comma VCC by RC. X-intercept is VCC, Y-intercept is VCC by RC. What is the minimum voltage we can apply to this transistor? 0. What is the maximum voltage the transistor can operate? VCC. What is the minimum current we can observe in the transistor? 0. What is the maximum current we can observe in the transistor? VCC by RC. On this line, every point is representing the operating point of the transistor. So this line is drawn in order to select the operating point very wisely and properly. If I select the operating point here, the transistor will be in the saturation region, the signal will not be properly amplified. If I select the operating point here, the transistor is in the cutoff region, still the amplification is not proper. When I take the operating point in between these 2 points, if I take here, transistor can properly amplify the signal. So this point of operation, which is giving the output voltage and the output current across the transistor, is called as operating point. As it is mentioning that where is transistor is actually operating, this point is called as operating point. This point has also another name called as quiescent point. We also call that as a Q point. Whenever any person comes to you and says the operating point of this transistor is 3,4, that means the transistor is operating at 3 volts and 4 milliamperes. If any person comes to you saying the operating point of this transistor is 10,15, that means the transistor output voltage is 10 volts and the output current is 15 milliamperes. If you are designing a circuit for your practical project and then you are expecting the output 15 milliamperes, output 15 milliamperes, at that particular point, what should be the output voltage across the transistor? You can design in this line. In this way, we can measure exactly what is the output voltage and what is the output current when the transistor is operating as an amplifier by using this quiescent point or operating point.